The region bounded by the equations x is equal to y squared minus 5y plus 10 and x is equal to 6 is rotated about the y-axis. Find the volume of the resulting solid. Okay, so the first question that we have in this problem is, are the equations solved for x? Because we're rotating it about the y-axis, so we need everything in terms of y, and they are in terms of y. So that part is already taken care of. Both equations are solved for x, or in other words, in terms of y. The next step is to determine the upper and lower limits of integration by setting our two equations equal to one another. Well, if x is 6, then I can take 6 and substitute it in for x in the other equation. So we'll have that 6 is equal to y squared minus 5y plus 10. Since we have a quadratic, it's easiest to solve when we set it equal to 0. So if we move the 6 over to the right side, we'll have that 0 is equal to y squared minus 5y, and then 10 minus 6, which is plus 4. And we can factor this. The factors of positive 4 that add up to negative 5 are y minus 4 and y minus 1. And if we set them both equal to 0 and solve, that means that the y values for the upper and lower bounds of integration are going to be y equals 4 and y equals 1. This also tells us that because we have x equals 6 as one of our functions, or the equations that we're graphing, we have x is equal to 6 as this graph, or this line, and we know that it's going to intersect our horizontal parabola when y is 1 and y is 4. So this will be one point of intersection, and this will be the other. Okay. So next what we can do is find the vertex of our horizontal parabola. And we can do that using the different strategies we have for parabolas. We can use negative b over 2a. So negative 5 over 2 times 1. And this will be y equals, and this will be the axis of symmetry and the y coordinate of our vertex. So we're going to have negative of negative 5. So that becomes plus positive. So we have 5 halves as the y coordinate, or 2.5. So this is going to be our axis of symmetry in the parabola. And now we have to determine the x coordinate when it crosses our axis of symmetry. So if we substitute 2.5 or 5 halves in for y and solve for x, we'll get that x is equal to 5 halves squared minus 5 times 5 halves plus 10. So we'll have 25 fourths when we square it, and because we have fractions, we're going to need a common denominator, so we could write minus 25 halves, or minus 50 fourths, and then plus 40 fourths. So we have 65 fourths minus 50 fourths, so that's going to be 15 fourths, or 3 3/4, which is 3.75. So if I go to 3.75, that's going to be the x-coordinate of my vertex. So we've got this sideways parabola and this line, and here is the area that we are going to revolve about the y-axis. So the final solid that we're finding is going to look something like this. We have it on both sides there, and we're going to find the volume using our integration. So we can integrate, because our volume is going to equal pi times the integral. We know our lower and upper bounds are from 1 to 4, And now we have to do the outer radius, which is 6 squared, minus our inner radius, which is the y squared minus 5y plus 10 squared. And we're going to integrate this with respect to y. So now let's continue. We have pi times the integral from 1 to 4. When we square 6, we'll get 36. And we're going to subtract. If we multiply this whole thing out, it's going to end up being y to the 4th minus 10 y to the 3rd plus 45 y squared minus 100y plus 100. And we're going to integrate this whole thing with respect to y. So the next line is going to be to change the signs of everything that's within the parentheses, with the exception of 36, because that stays the same out in front. It'll be minus y to the 4th plus 10y cubed minus 45y squared plus 100y minus 100. And again, we're integrating with respect to y. If we were to take 36 and subtract 100 from it, we will get negative 64. So I'm going to erase the 36 and rewrite the ending constant as minus 64 by combining those terms together. And now we can integrate this. So we have pi, and then we'll have negative y to the 5th over 5 minus 10y to the 4th over 4, which reduces to 5/2 y to the 4th, minus 15 y to the 3rd plus 50 y squared minus 64 y. And we're going to evaluate this from 1 to 4. All right, so if we have negative y to the 5th divided by 5 evaluated at 4, and with the division there, we'll end up getting pi times negative 204 and 8/10 minus 5/2 times 4 to the 4th is 640 minus 15 times 4 to the 3rd is 960. Plus 50 times y to the 4th, which is 16, is going to be 800. Minus 64 times 4 is 256. So I'm going to keep the square brackets there. So that's one value we're going to get. And then we have to subtract from it. 1 to the 5th is 1. And 1 divided by 5 is 1/5 or 0.2, and we have negative, so negative 0.2 or negative 2/10 minus 5/2, which is 2.5. Oh, whoops, I'm sorry. This should be a plus here and a plus here, because when we integrated, this was the 10y cubed. So it was plus 5/2 over 4 instead of minus. So this should be a plus 2.5 minus 15 plus 50 minus 64. And when we evaluate the first set of parentheses in a calculator, we'll have 19 and 2/10 minus negative 26 and 7/10, and minus the negative becomes plus positive. So we'll have 45 and 9/10 times pi, which is approximately equal to 144 and 199 thousandths, or answer choice A.